why you should use a network diagram. There's more to a project manager's role than just network diagramming. And we often refer to this triple constraint. And if you attended previous seminars, you know this is one of my favorite slides because the iron triangle, or the triple constraint, is made up of scope, time, and cost. Well, obviously, time is our schedule. A change in one of these legs of the iron triangle or triple constraint will drive a change in one of the other legs, or at least one of the other legs, if not both of the other legs. So if I change scope, undoubtedly it's going to affect cost, and it probably will affect schedule at the same time. But as a project manager, you're managing more than just the triple constraint. You are balancing a lot of balls at any one time in your project. You're balancing cost, schedule, scope, resources, quality, risk, stakeholders, and change. This is important. Our schedule baseline, which contains the project network diagram as a part of it, the schedule baseline is one of the triple constraints. It's one of the baselines. In other words, we create this schedule baseline, and of course these three baselines together make up what we call the performance measurement baseline. The performance measurement baseline is basically how the project is performing. It's looking at the entire project, not just one item, but it's looking at the entire project. And it will give us an indication then how it is performing. The schedule management plan. The schedule management plan is going to tell us how we're going to create the project schedule. There's two things that you need to understand at this point. One of them is the process that gives us the schedule is called develop schedule. Well, develop schedule has two outputs. The schedule baseline, and it also has a project schedule as the output. The project schedule is made up of three different types of schedules. It's a document. One would be the Gantt chart, one would be the project network diagram, and one would be the actual milestone list. Those three things make up the project schedule, which is a document. You could ask the question, and rightfully, what makes up the schedule baseline? What's the difference between the project schedule and the schedule baseline? The project schedule may be the baseline. It could be the same. Or you might choose one or the other of the three types of schedule to be your schedule baseline. This schedule management plan is a high-level document or a high-level plan. It is part of the project management plan, but it gives us high-level information on the schedule, how to develop the schedule, how to complete the other schedule processes. You see, there are several schedule processes that will contribute to the project schedule. Here is the schedule management plan. This is the structure of it, according to the 6th edition of the PMBOK Guide. First of all, the project charter is going to be a contributor because in the project charter, it will identify perhaps milestones that we have to meet. Milestones meaning when this project has to be finished or when certain things have to be delivered. It may have other constraints as well. It does have a very brief description of the project too and the product, but we have to then get into the details. Of course, we're working on the schedule, we're working on the project network diagram. We know now at this point what our WBS is going to look like and what our WBS dictionary is going to contain and things like that. Through that tool called Progressive Elaboration, we're learning more and more about the schedule. We're also learning more and more about the previous work we've done in planning this project. And of course, Progressive Elaboration says, as I learn more, I update to reflect that new information that I have learned. Other primary input here would be project management plan, what is available of it. For example, we have a developmental approach. Developmental approach is how you're going to manage this project. Are you going to manage it as agile? If you do, you're not going to be worrying too much about the schedule. Are you going to manage it as a predictive or traditional or waterfall? All three of those are synonymous. If you are, then you're going to have a well-defined schedule. Are you going to manage it as a hybrid, in which case it will be made up of both the predictive and the agile approach as well? In that case, the predictive approach would also need the schedule. We have to understand how we're going to be managing this project. Then, as an output of this process, we have the schedule management plan. The schedule management plan then tells us how the schedule will be developed, how it will be managed, how it will be executed, how it will be controlled, and it also gives us a level of the variance information. You see, we may have a threshold there. As long as we stay within that threshold, we don't have a variance. We exceed that threshold, then we have a variance, and we have to take action through a change request to correct that variance. You can see it's pretty straightforward. What is the methodology? What tools am I going to use? Am I going to use Microsoft Project, Smartsheet, Soho, Primavera? Exactly what am I going to use? The level of accuracy. Am I going to estimate it within a day, within hours, within months? What is the units of measure? What is that variance threshold we mentioned? And then our schedule reporting format. And of course, I just mentioned that those formats would be, of course, Gantt chart, the P&D, project network diagram, and the milestone chart. How will they be used? But look at this. How will we perform the other processes of schedule? If you had the schedule framework or the project framework from the 6th edition, you would see that as far as the project schedule goes, you have several different processes there. You have, for example, plan schedule management, which is what we're talking about. That plan tells you how to define activities, how to sequence activities, create the P&D, how to estimate activity durations, how to develop a schedule, which gives us our schedule baseline, and then how to control the schedule itself. Very important information is contained in this schedule management plan. Sequence activities is all about the project network diagram, and that's where we're going. That's what we're going to focus on today. We put the activities in the order in which they will be performed based on their dependencies. We have 3 types of dependencies. For example, we have mandatory dependency. Mandatory dependency, you have to do it that way. You don't have an option. It's mandatory. If I'm building a house, I have to pour the footing before I can build the foundation. If it's a discretionary dependency, there's a preferred way to do it, but we can do it another way. For example, I prefer to paint the inside of the house before I put the flooring down. That way, I'm not going to damage the flooring by the paint. If I'm doing the painting, you better do it that way because it ought to be mandatory because I am a sloppy painter, okay? And I get paint all over me and everything else. But a discretionary dependency says I could put the flooring down first, then paint the inside of the house. Then the third type of dependency that really will impact this project network diagram is an external dependency. It's external to the project. It's external maybe to the organization. You are dependent upon whomever is going to be doing that project or that part of it. You're dependent upon them to be available when you need them or whatever it is you need to use, depending upon it to be available when you need it. That certainly comes into play as we create this project network diagram. Structure of this process. This is out of the 6th edition of the PMBOK guide. You can see that the schedule management plan is an input here. It tells me how to do this process. I have the scope baseline. That scope baseline is made up of the WBS dictionary, and the scope statement. Well, guess what I'm going to do with that WBS? I'm going to decompose those work packages down into individual activities, and then from that I will sequence those activities. When I decompose it down into the activities, I'm creating the activity list. This activity list then will be what I use to sequence the activities in the project network diagram. The activity attributes here is a companion document to the activity list. The activity list has the list, and that's it. The list is not sequenced. They're in random order. Doesn't have a lot of information, but this activity attributes will have the details for each activity. Each activity will have activity attributes associated with that. It has the details such as sequence, perhaps. You may do some sequencing there. You may also have the details of what you're going to do to execute that, the resources that you need to do it, both physical and human resources. There'll be a lot of information in that activity attributes that you need to understand. So then another important thing would be the assumptions log. What are the assumptions I have made or my team has made with regards to this project? Assumptions are things that we believe to be true. And then the milestone list, if we have one at this point, would also be an input into sequence activities. The tool is Precedence Diagramming Method, PDM, Precedence Diagramming Method. That's where we create our network diagram. The dependency determination we talked about, mandatory, discretionary, and external. Leads and lags, we'll look at that later, but leads and lags basically says if it's a lead, activity B starts before activity A is finished. If it's a lag, activity A finishes, no work is being done, then activity B starts. For example, I pour the footing on the house. I have to allow that concrete to cure for a period of time before I can build the foundation itself. A lead, I finish painting one room and I'm starting to put the flooring down before I have finished painting the inside of the house. That would be a lead. And then, of course, project management information system is where you're going to store all of your projects. And the output, project schedule network diagram. And we have project document updates, progressive elaboration. As I'm doing this process, I learn more and I update to reflect what I have learned in the appropriate plans and documents that are impacted. Sequence activities is what we're talking about. Project network diagram. Establish the dependencies of each activity. We talked about mandatory, you must do it in that order. Discretionary, you may deviate from the preferred order. And external is external to the project or organization. We're going to assign predecessors and successors. We need to know what those are, and we will create that and align that in the network diagram. That's what we will use to create it. We need to also establish any leads or lags. Once we have this network diagram completed, then we can determine the float for each activity. If you talk about float is how long an activity can be delayed before it will become a critical path item. How long can an activity be delayed before it becomes a critical path item? That's what we're trying to do, and that's why we're driving forward with this project network diagram. That's one of the reasons, at least. We're looking at the different relationships of activities that we need to understand. Define logical relationships. For example, we have a finish to start. What that says is activity A has to finish before activity B can start. That's what we'll be working with today in our network diagram that we're going to work on. That is the most common, used most often. Then we have what's called start to start. A has to start before B can start. An example of that is the writing of a report must start before the review of the content can start. Then we have start to finish. Activity A must start before activity B can finish. Now, you manufacturing folks, you generally have leads over your different operations in the factory. A shift lead cannot leave until B shift lead comes on and they do a turnover. That's an example of that. Then we have what's called finish to finish. The sheetrock must be installed before the painting can finish. That would be an example there. But the most common, again, is the finish to start, and that's what we will talk about later. What are the benefits of a network diagram? I know everybody here probably uses Gantt chart formats. I'm sure you do. And probably most of you have never done a network diagram other than in the classes that you've taken. Do we need to do a network diagram? First of all, it's going to assign the start and finish date to each activity. It shows the interrelationships of the activities, the dependencies of the activities. It gives us a great visual of progress and interdependencies of activities. It is a validation of the project time schedule. It really shows us a pictorial view. We can understand the opportunities we have to balance our resources. One of the ways that we balance our resources, there's two ways really of schedule compression. One of them is called fast tracking. Fast tracking, we will work activities in parallel with each other. The other one is called crashing. Crashing, we just throw more resources on it. Maybe instead of using one paint crew, we use two paint crews. Crashing increases the cost, obviously. And if I'm working on a project that's cost sensitive, that's not something I can do, is it? When I look at fast tracking increases risk. Let's say that I'm working on a database, and there are certain programs that connect the database, different databases. I'm still building the database, and I start working on the program that will tie all these databases together. As I am creating the databases, I may make changes to something that would require you then to go back and redo the programming. When I work things in parallel like that, then I am increasing the risk. Fast tracking and crashing. But those are tools that we can see better opportunities in a network diagram that we can use those tools as appropriate for our project. We also have a visual of the float for each activity. We understand each path through the project. It is very common to have many different paths through a project, and some of them are parallel, some of them are linear. But we need to understand that, and that will help us to visualize perhaps float as well as use that as an opportunity to optimize the activities. We're going to talk about early start and early finish, and late finish and late start. Project network diagram. The first thing we have to understand is we always have two milestones in a project. Remember, a milestone is a marker. It has no duration. It's strictly a marker. We have the start and we have the finish. Based on the start date, the duration of all the activities, the longest path will drive the finish date. We have a network diagram chart over to the right here, and this is what we call a short name. For each one of these activities, A, B, C, D, E, F, those letters represent some activity in the WBS. There's a legend somewhere that's going to identify what A relates to, what B relates to. But we would write those activities down And then we're going to start looking at the predecessors. What precedes each of these activities? That's what we have to determine. If I look at activity A and activity B, and I say, what precedes activity A? What precedes activity A? And I'll see that start precedes activity A and activity B. I'm going to draw in then my lines here. I have activity A and activity B in the diagram. I change gears a little bit. I ask the question, what does activity A precede? I look over here and I see that activity A precedes C. I put in C. Then I ask the question, what does activity B precede? Over here, B precedes D. I draw in D. Then I ask the question, what does C precede? Well, now I see that C precedes two things, doesn't it? C precedes E and C precedes F. I'm going to put F in here, or E in here, and then I'll draw my line to it. Then I'll put F in, draw my line to it. I noticed also that E precedes F as well. Does E precede something else? Yes, E precedes G. What precedes G? We look at that and we see that D precedes G as well. So right here, D and E precede G. Then we ask the question, what does F precede? F precedes H, and G also precedes H. G precedes I also. I put I in, my line to I. Then I ask the question, what does H precede? H precedes finish, and then I have J that also precedes finish. I, what does I precede? You can see I precedes J, and then those two precede finish. Step by step, we go through and we determine the actual sequence of the activities. When we create the activity attributes, then in that we may actually address the relationships. That's where we may actually determine the predecessors and successors in the activity attributes. Potentially, that's where we will do it. If not, we're going to have to do it in a chart similar to this and establish those based on the requirements, based on the dependency. Our next step is going to be the duration. In this case, our duration is days. We'll put the durations up over the top of each of these activities. The duration estimates come from the process that's called estimate activity durations. When we estimate activity durations, we're taking effort, such as it takes 40 hours to do an activity. Well, if I work that activity straight through from start to finish, 40 hours after I started it, I'd be done with it. But I'm not going to work it continuously. I have breaks, I have lunch, I go home at night, I may have weekends in there, I may have resources that are not available for 2 or 3 weeks, physical resources, I may have some holidays, vacation, and I may only be working on this project 10% of the time. That actual 40 hours of effort can turn into 6-8 weeks of actual duration. I'm interested in the duration because that's what's going to drive my finish date of this project. That is the duration of each activity. Where do we go to from here? Next thing we want to do is we want to establish the different paths through this network diagram. It may seem simple, but there are actually several paths through this diagram. I have A, C, F, H, finish. I plug it in down here. Start, A, C, F, finish. H, finish. I have another path. Start A, C, E, F, H, finish. I plug that in. I have another path. Start A, C, E, G, H, finish. I plug that in. Another path. Start A, C, E, G, I, J, finish. Then I have start B, D, G, H, finish. Plug it in. Then I have start B, D, G, I, J, finish. I have 6 paths for this diagram. What I want to do is I want to determine the critical path. The critical path is the longest path through the project. Based on the start date, the critical path will define for us what the end date of the project will be. If any activity in the critical path is late, the project will be late. I also have near critical paths. Near critical paths we also have to manage very closely, because a near critical path, if anything slips in it, it could soon become a critical path item. It's common for projects to have many different critical paths. It's also common for projects to have many near critical paths. A project manager has to be on top of all these particular activities that are critical path or near critical path to make sure that they don't slip and that we're able to finish it on time. Let's see if we can determine what the critical path is through this project. To determine the critical path, we come in and we add up the duration estimates. The duration estimates on the top of each of these. If I add up the first path, ACFH, you'll find that it has a duration of 38. The next path, ACEH, has a duration of 46 days. The next one, ACEGIJ, has a duration of 43 days. The next one, ACEGH, has a duration of 40 days. The next one, Start DGH Finish, has a duration of 34 days. And then the last one has a duration of 37 days. What's my critical path? The longest path through the project. The Start ACEFH Finish is 46. That is my critical path. I have another near critical path right here that I also have to watch out for in my project. Isn't that a nice picture of the project? It sure is. And that picture can tell you a lot, and we will go further with this, and you'll see some of the things that it will tell us. We want to look at early start and early finish. Early start, ES, is the earliest start date for an activity based on the activity's duration. But to calculate early start, we do a forward pass. We'll also look at late start and late finish. We'll also look at that, but let's focus here just for a minute on early start and early finish. Early finish is the earliest finish date based on the activity's duration. Once again, to calculate early finish, we start on the left and we move to the right. There's a couple of different ways of doing this. I prefer to do it, obviously, the way I'm going to show you. Some people start off with 0. I don't like that method. I prefer to start off with 1. What we're going to do is a forward pass. We're going to add the duration to the early start, and we're going to subtract 1 to determine the early finish. If the unit of measure is in days, it's in days. The activity always starts at the beginning of the day. At 1200 a.m., the activity starts. It always finishes at the end of the day. At 11:59 p.m., the activity finishes. Keep that in mind as we do this. Using this forward pass formula here, I will add the early start the duration to the early start, and subtract 1, which will give me the early finish. So remember, start is a milestone. It's 1. The early start of A is 1. Using that formula, I add 1 and 5 and subtract 1, and that gives me 5. Simple, right? The activity starts at the beginning of the next day. Activity B will then start on day 6. 1200 a.m. it starts. Using this formula, I add 6 to 10, that gives me 16, and I subtract 1, and that will then give me 15 as my early finish. Early start of C, it will start on day 16. At 1200 a.m. it starts. I put in 16. I add the duration to 16, gives me 20. I subtract 1, so my early finish is day 19. This project starts on day 1 and it will be finished on day 19 based on the durations for each of these activities. Let's look at late start and late finish. Late finish and late start. LF is the latest date an activity can finish without delaying the late start of a subsequent activity or the project finish date. To calculate late finish, we do a backward pass. We move from right to left. See my late finish, late starts at the bottom. Late start is the latest start date for an activity based on its late finish and duration. Again, we do a backward pass. We do just the opposite if we're establishing the late start and late finish. We add 1. To do the early start, early finish, we subtracted 1. To do the backward pass and plus 1 using the duration estimates. We said that this project finished on day 19. That was our finish date of this project. My late finish of C is going to be 19. I subtract 4, add 1. That says that my late start is 16. The late finish of B will be the preceding day. That will be 15. I subtract the duration of 10, add 1. That gives me a late start of 6. The activity A will start the preceding day for the late finish. It'll be 5. I subtract the duration and add 1. That says that my late start of activity A is 1. What do we do with this information? Once again, we're going to look at this network diagram. We have our duration estimates at the top, and we're going to discover what the float, total float, slack, or total slack is. Float, how long an activity can be delayed before it becomes a critical path. Start off here by doing the paths down at the bottom. We have our paths through this project. Then we calculate the actual duration of each of these paths, what we did in the previous slides. We have determined that activity or start ABCI finish is the critical path. Remember, we went through each path, identified it, we added up the durations for each path. That gave us the duration estimates that we see right here. Float is the difference between the early start and late start, or early finish and late finish. Either one. Either one of those will give us the float. Our early start of A is 1. Our early finish is 5. Add the duration, subtract 1. My early start of B is going to be day 6. Add the duration, subtract 1, be 15. My early start of C is going to be 16. Add the duration, subtract 1. That says that my early start of I is going to be day 20. Add the duration and subtract 1, which is 27. Day 27, That's when we will finish this project based on our start date and durations. Using the rules I gave you, the late finish of I will be day 27. The late start of I, if I subtract and add 1, will be 20. The late finish of C will be day 19. The late start of D will be 16. The late finish of B will be day 15. Subtract the duration and add 1. The late start will be 6. The late finish of A will be 5. Subtract 5, add 1, and the late start of A will be 1. We have activity D. The early start is 1, the early finish is 5. E, the early start will be day 6. The early finish will be 11. Add the duration and subtract 1. The early start of F will be 12. Add the duration, subtract 1. The early finish will be 13. H will be day 14. Add the duration, subtract 1. Will be day 17. The question we have to ask is 17 greater than 27? According to my math, it's not. 27 is still the finish date of this project. Late finish of H will then be 27, the finish date of the project. My late start, subtract the duration and add 1, will be 24. The late finish of F will be 23. Subtract the duration and add 1. It will be a late start of 22. The late finish of E will be day 21. Subtract the duration, add 1. It will be late start of 16. And then the late finish of D will be 15. Subtract the duration and add 1. The late start will be day 11. We got one more to go. Looking at this chart, I see that the early finish of E is 11. The early finish of G is going to be day 12. Add the duration and subtract 1. The early finish of G will be day 15. Look at this. Does that change the early start of H? Yes, it does. H goes from day 14 to day 16. Early finish here of 15. H is going to be day 16. That's going to change the early finish of H to 19. Is 19 greater than 27? No. My late finish of H will still be the same. My late start of H will still be the same. The late finish of G will be day 23. Subtract the duration, add 1. The late start of G will be day 20. Does that change E? Yes. We'll have day 19 here. That will change 16 then to 14. That will change 15 then to 13 and 11 then to 9. I have established the early start and the early finish of each of these. I want to understand, what is the float? Look at this. 0. I subtract the early start from the late start, 0. I subtract it again, it's 0. 0. 0. There's no float on that path. That path is the critical path. There's no float in the critical path. Let's look at D. What is my float of D? 8. 1 from 9 is 8. E, the float is 8. F, the float is 10. 12 from 22. H, the float is 8. 16 from 24. G, the float is 8. 12 from 20. That's how we do float. There's a better way, easier way, and I'll show that to you in just a minute. Critical path, it is always 0. Is an alternate way to calculate float. We do the network diagram, we establish the paths through the project. We have established what the critical path is. We have established the paths, we've established the critical path. We ask the following questions for each activity. Is the activity on the critical path? If the activity is on the critical path, the float is 0. The items that are on the critical path are A, C, E, F, H. Any of those activities, the critical path, the float would be 0. Then we ask the question, is the activity on more than one path? If it's on more than one path, we take the longest path through the project and subtract that from the critical path, and that will give you the float for that activity. If the activity is only on one path, you subtract that from the critical path, and that will give you the float. Let's try that. What is the float for B? Is B on the critical path? No. Is B on more than one path? Yes. What is the longest path? 37. 37 from 46 gives us a float of 9 for B. What is the float for I? Is I on the critical path? No. Is I on more than one path? Yes, it is. What's the longest path? Right here. Subtract that from 46, that gives me 3. The float of I is 3. What is the float for G? Is G on the critical path? No. Is G on more than one path? Yes, it is. What's the longest path? 43. That says my float of G is 3. What's the float of H? Is H on the critical path? Yes, it is. The float is 0. That is the best way then to calculate the critical path and the float for each activity.